Blockchain. We're writing our own blockchain. That's what we're doing. We're writing our own blockchain today, and we're jumping right in. I want to get the schema done today. That's the main task. We got one task today to do. We've got to get the schema. If we get the schema, we're good. I would be very happy if we define our schema today. And so I was just looking over here at our SQLite, which is going to be our ledger. We're going to use SQLite for our ledger. Might as well, right? Might as well. I'm actually pretty excited about this. We'll start out with something simple. We need to get our schema going. So I'm going to copy some example starter stuff here. And then if we can get our schema going, at least write our schema file. Actually, let's just go ahead and open up a new file. Let's see. Where should we put it? For now, we'll just put it in schema.sql. Let's make it easy. Schema.sql. Perfect. All right, here we go. All right, so this will be transaction. So we'll do transaction, right? We don't need a primary ID because, and then dash is going to be schema for the transactions. No, this is going to be the main ledger. We need a from address and a to address, right? Okay, so from address. Let's see if we can, we'll do something like from address. And this will be, we need it to be a very specific size because when we're defining what it's going to be, so it's going to be a var, I think it's varchar. Let's see, varchar. And then we need to know how big is it going to be. We need to know because it's going to be something like 32. I don't know what the exact is going to be on that. It'll be around 32. We need the to address, right? And then that's going to give us the ability to transact currency between them. We're going to transact. Oh wait, this will be and we amount, which will be the amount, and it needs to be what do you call it? Like a double? Can we do doubles? Wait, what is it? We'll find out, won't we? We will have a data section, which is going to be, see, you are using SQL for DB. Yeah, you are. We're going to be using a ledger. Our ledger will be defined with SQLite. We'll be using SQLite, which is more than sufficient. It can easily handle the scale that we're looking for. It can be very good. And it can help us do some other things too, right? It can help us define some pretty cool data analysis if we ever needed to. I'm quite clueless about the thing you said. Could you please explain it in a simple way? Super V Gaming? All right, you've heard of Bitcoin, right? You heard of Bitcoin. We're making our own Bitcoin. That's what we're doing. We're making our own Bitcoin. And it's we're writing our own algorithms. We're going to have all of it. It's going to be custom written. Are you making your own cryptocurrency? Yeah, we are. We're making our own crypto, and we're not going to do some like ERC20 token or anything like that. We're really going to make our own blockchain, and we're writing it all from scratch. I was realizing the other day, I'm like, how would I make a blockchain if I was to make my own cryptocurrency? And then I just realized I kind of know how to do it. I know enough to be able to make it happen. So we also want code. So or maybe call this contract. Maybe we'll do code. We'll just call it code. I'm figuring out code. So this will be text, right? It'll be text, and it can be null. It can be null. It's fine to be empty. It's fine to be empty because we're gonna have smart contracts in Lua. Oh, we also want code language will be something. I always thought how actually they were made, actually how they are worked. Yeah, guess what? We're gonna do it. We're gonna make it here. We're making it now. We're defining our schema for our ledger. That's the main plan today. So actually what I need to do is I need to see what the public key is, the public key length for this. We need to define, this is critical. Now we can jump back in. We have to get our schema going. So one thing I needed to do was figure out how long the from and to address is going to be. We can do that because we know what this library is here. So let's pull this up really quick. We need to go here. Let's go here. I want to pull in this library here. All right, where is it? It's this one right here, right? Let's double check. Yes, Sphinx Plus. This is it, Sphinx Plus. Pi Crypto. Post-quantum signature schema Sphinx Plus. This crate contains bindings to the C implementation of the following schemes. Okay. But this one is a Rust implementation. This one's better. This is the one we want. So we've got the right one. This is the Rust implementation. Perfect. All right. Here we go. So public key size. Okay, so if we go with the small key size, it's going to be this big. Should we go bigger? Should we go to 64? I think we should probably make it 64 just in case. So this is the public key size right here, 64 bytes. 64 bytes. Perfect in PyTorch. Ooh, very nice. PyTorch is a very challenging framework. I'm still getting to know about it. It's actually really great. to learn. So thank you. Excellent advice. All right, so let's put it up to 64 just for future proofing. We'll do some future proofing here. So we'll pipe this over here to 64. And here we go, 64. Done. All right, from and to address. So these will be the public addresses. The amount is it. So how do we get the biggest floating point and biggest float value? Thank you for the likes in SQLite data type. What is it? Is it double? Is it real? It's called real. SQLite's real data type used for floating point numbers stores values in 64 binary 64. This format is also commonly known as double precision floating point number. All right, so we want to call it real. Here we go, you guys. We're making it real. All right, boom, real. There it is. Amount in real. The amount is real. Now it means now we can go down to 64 bits. Or 64-bit floating point number. 64-bit floating point number. Data. I also want note. I want a note here, and the note will be a varchar, and it will go. Can we go up to 256? We'll just say we can. We'll just say we can go up to 256. Thank you for likes, you guys. Anything for DevOps? Oh, we did. We had those roles, but they just got filled. Mohammed, they got filled in. We hired them. We did. There might be more in the future, though. You never know. I'll let you know. I'll let you know if there's new. I'll let you know if there's any new ones in our company. So it took me 2 months to understand everything. I really did practice by myself to learning Daniel Bork course. It does. So AI is a challenge. It's a big challenge. But it's worth it. It's worth it. It's so much fun. And once you get the grasp and the understanding of it, you basically, you can do anything you want in the whole world. You have full control. You basically are a wizard. So let's jump back to our project here. All right. So we've got a note, which is just like basic, any details, right? Any details about the transaction. I mean, you could put anything you want in there. Let's see here. Text. So this will be actual code, right? This will be the Lua code. Here we go. The Lua source code. So, and this is the thing I don't know about. This is the thing I'm not sure if I want this. Let's comment that out for a second. Let's just comment that out for now, because I'm not sure if I want that. Data. So we could also store data. Lots of data. So if we want to add some data so not only will we be able to access the data that we store in our code, right? So let's go up here. Let's add this. So this is going to be the smart con. We've got our signature, and we got our data. So this is our signature. What is the output of the signature, right? Did we get that? Signature bytes. Oh, that's a lot of signature bytes. Okay. So it's a pretty beefy signature. So if that's the signature byte size, wow. All right. It's Bobo Bear in one. Oh, it's Bobo Bear. Okay, Bobo Bear. Sounds good. How do you sell this initially? How did you get first leads? I assume this is all B2B. It is. It's all B2B. We actually had gaming companies do multiplayer games as our first customers. And it's one of the challenges when you're starting your own business. Thank you for the likes, you guys, is to make sure that you spend a lot of time on marketing. You need to spend enough time on marketing. Thank you for the likes, you guys. If you don't, and you spend too much time building your technology, you'll have the best technology in the whole world that nobody's ever heard of. So, got to make sure that you spend your time marketing. You work alone or you have employees. We got employees. We've got a lot of employees. We're doing good. We've got hundreds of employees. We're okay. We're on our way on the chain up to the rocket. We want to. One day, maybe we can IPO. One day we might IPO. You never know. Okay, focused on coding time. Let's see if we can get to the main bit. I know we got to get our schema defined. You got it, Kevin McAllister. Let's see here. I need some work. Oh, Rip Baba. I also need. Well, I mean, I've got work. I've got work to do. I'm hanging out with you right now, guys, and not actually doing the work that I should be doing. We're over here. All right, so I need the signature. It's not going to be 128. It's going to be very big. What do you do, Bobo Bear? I own my own company. I own my company here. So this is my company. We're a communications company that enables other businesses to power communications between devices. So food delivery, multi-user collaboration, gaming, right? We got gaming, you got sports and media, everything. You can check out Node-RED, guys. Hidden gem, free and open source IoT management and web programming platform developed by IBM. Yep, can do anything you want with JavaScript, efficient using Node-RED. Got it. Code Langston, you've been around. Node-RED's actually came out more than a decade ago. That's pretty old. Node-RED's been around. Is this channel part of the marketing? Well, I mean, technically no, because this is my own personal YouTube channel. This is my own personal YouTube channel. So we got PubNub YouTube. We got PubNub YouTube, right? We've got our own separate YouTube channel over here. There's a book. Yes, exactly. Code Langton's entropy. Rust has a book on building blockchain. So that's basically what we're doing. We're building our own, what you call, for layer 1 blockchain. That's what we're building. It's a layer 1 blockchain. So this needs to be, what is this? Let me double check where we got this. It needs to be 7856 for this one. It's for the 128 simple. Okay. So here, this is what we need. Right here, this is a very big signature. It might be a smidgen more than I was thinking we needed. It's just a smidgen more, but we'll find. We'll just keep it. We'll see how it goes. We'll keep it. So we got our signature from and to address. We get the amount. We get a note, which would be a detail by note. We got a blob. See here, blob for if you want any like binary data or something that you want to bring along with your smart contract, right? The code for the smart contract. Lewis is good for smart contract. There we go. And I think I'm just gonna not have the code language. What are we missing? We need a salt. We need a time? We need a timestamp. We need a timestamp. All right. It should be a Unix timestamp. Is what it should be. It should be a Unix timestamp is what it should be. Monotonic timestamp. Yes, Kevin McAllister, we got to do a monotonic timestamp. It's got to be monotonic. The good news is I've got a data source for the monotonism that ever increasing. So we need timestamp. I don't know if I want it to be a date time. I think I want it to be a number, like an int. Can we do int? Or no, let's see. We need to look this data because we can't make a mistake here. Unix best data type. Best data type for Unix timestamp SQLite. Here we go. What is the best data type? What is it? I think it's going to be. Oh, it is an integer. Did I get it right? Is it integer? Reason for Unix timestamps are inherently integer values, but it needs to be a 64-bit integer. Is the problem, right? It says integer. All right, it says integer. I'm concerned because what about with the 32-bit length? Well, I think we'll be fine. We've got our timestamp. We've got our amount. We've got a note for any kind of just like note for the reason for the transaction if you want. And then we've got our smart contract. We've got a code for Lua, and then it's got to be text, right? Lua code. We've got our signature from and to address. What else do we need? 40 minutes now, Kevin McAllister. All right, let's see what else we need. Let's see what else do we need. Let's look up. Let's use the internet for research. Okay, so we need the Bitcoin ledger schema. What does that look like? What are we missing? Because we're inspired. We want to see version. Okay, so we should have a version. We need the version. We need the version. We could do version. Yep. Previous block hash. So I guess we need to think about our block sizes and if we want to do blocks or if we're only going to be doing single transactions. So we could do real-time blockchain or real-time chain, right? We could do a real-time chain and not require a block or a block size of 1. We could make the block size of 1. So that's something. Merkle root. What is this? Root of the hash of the Merkle tree, which is cryptographic summary of all the transactions on the block. This ensures transaction data is tamper resistant. We do need to have the chain, right? So the Merkle root is like the root node we discussed about in the beginning. Okay, from yesterday's stream. All right, so I need to understand this better. So let me add this as a to-do item. To-do Merkle root. See here, the root hash. I mean, we could have like the OG hash, which is I don't know. We'll figure that out. The kickstart, right? We got to kickstart it. We might need to kickstart it. We don't know about the kickstarting though, but we'll see. So we've got, this is the to-do item here. So let's see, to-do, paste, paste. So we need to figure it out. So do we add a timestamp difficulty target? We should add this as well, I think, in a nonce, a 4-byte number that miners adjust to find a valid block hash that meets the difficulty target. Okay, so we do need these things. We do need these things. I know the nonce I get. I do get that. The nonce. All right. So we want difficulty. So we do, let's do this. Wait, set, no paste. Here we go. Let's close some things up here. I'm going to wrap this up really quick. Here we go. All right. So we want difficulty target, but we're just going to call it difficulty, and it will be an integer. Let's pipe this up here. We need this up here. We need to put this, the important stuff needs to go at the top. Timestamp. So that counts there. And then, well, you know what? I mean, here, we'll organize it later. And then nonce. We need the nonce. So that, do NONCE. Although I think it could be, I don't know if we want it to be a 4-byte. Thank you. I got to click these, got to click the buttons now. Like, reply. Thank you. Explanation point, and we put some party poppers in there. We do another party popper, and then another party popper. Thank you, Code Langton's entropy. There we go. Code Langton's entropy. Thank you for that. What do you do? What did you do that for? That was so amazing. I appreciate it. Make it so everyone on Earth can have 100 units, so you don't have to use millicoins to use it when all is mined. Might be right. Love and peace. Thank you. Appreciate it. That is a really, really positive thing. What are try? Wait, what do you mean? Wait, what do you mean? What? So we succeeded here. I think we did a really good job. I think we got a really good starter schema, and it's all in a single table. We don't need to do any sort of denormalization or normalization. Let me commit this really quick to our. Let's do here. Get status. All right. Get. Add period get status again, get commit. All right, we added our schema starting point defined successfully, and then we will add a party popper. There we go. Push origin main done. All right, we did it. What language are you using? Rust. We're using Rust. When you on next? Okay, so what? Same time tomorrow. Let me check. Let me see about the same time tomorrow. Let me double check. Let's find out, you guys. Let's find out when we're live. Oh, tomorrow is Thursday. That's a really hard day. Thank you for all the likes. Awesome channel. Thank you so much. Appreciate it. Yeah, we're going to be doing more Rust tomorrow. We're going to be continuing to build our